Welcome back. We are going to be we're going to continue graphing actually. This next section is solving equations by graphing, so it's going to be a good review for your quiz tomorrow. But first let's start with the bell work, which had fractions in it, which is good practice. Y equals -½ x squared plus 6x plus 3. Okay, so find the vertex. X equals -b, so -6 over 2 times -½ Well, 2 times -½ they're just going to cancel each other out, and we're going to get -1. So the x value of the vertex is +6. So you should have gotten that. So now we find the y value. Y equals -½ 6 squared is 36, plus 6 times 6 plus 3. So this is going to cancel out to become, what's that, 18? So -1 times 18 is going to give me -18. 6 times 6, 36, plus 3, -18 plus 36. Oops, sorry about that. -18 plus 36 is +18 plus 3 equals 21. So my vertex is 6, 21. Oh, that's big. So I make my chart. I put 6 in the middle, right? Because it's my axis of symmetry, 6, 21. Okay, I go 2 below, 2 above. So 5, 4, 7, 8. Okay, so these are a little bit bigger numbers and there's no y-intercept. That's a shame, but that's okay. We just have to do a little bit more work. -1/2 times, well, what is 4 squared? 16. Plus 6 times 4 plus 3. So that's 2, that's 8. So we get -1 times 8. -8 plus 6 times 4 is 24. Plus 3. -8 plus 24 is 18. No, 16. 16 plus 3 is 19. 4, 19. Boop, 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 boop. Okay, so you should have done this in bell work already, so that's why I'm speeding through this. Plugging in 5. Let's do it in a different color. Okay, 5, so -½ Oh, wow, that's going to be annoying. Okay, -½ 5 squared is 25 plus 6 times 5 plus 3. Okay, so -½ times 25, does it cancel out? No, it doesn't. So we get -25 over 2 plus 30 plus 3. Now remember, I told you that commutative property of addition, as long as it's addition, says you can add in any order. So we know it's -25 over 2 plus 33 over 1, which means we have to make them both, I'm just going to start writing up here, which means we have to make them both 2, because that's going to be the least common denominator. So I've got to multiply 33 times 2, so that's going to give me 66. Okay, so -25 plus 66 would be 41, positive. Now again, we don't know necessarily how to graph an improper fraction like that, so we have to make it a mixed number. So 41, the closest to that would be 40, even number, right? So that's going to be 20. 40 divided by 2 is 20. And there's 1 left over, so 20½. So our order pair for 5 is 20½. And does that fit in with our numbers where they're going right now? Yeah. So we're probably pretty sure we did it right. But now we're dealing with integers. Remember, we dealt with fractions the other day, and that makes it a little harder. But if it's 1 below, 1 above is going to be the same, right? So 7, 20½. 2 above, 2 below, 8, 19. So there are all our ordered pairs. Let's go ahead and graph it then. Okay. Move this up. Okay, so let's see here, we're all in the positives for x, all in the positives for y, so I'm just going to draw that then. Make sure you're using a ruler when you do this. Okay, so let's see here. I gotta get up to 20, so I'm gonna count by twos. 2, 4, 6. I'm gonna count by, let's see here. Can I get to 8? 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so I'm gonna count by ones. 1, 2. Okay, so 4, 19, 3, 4, 2, 4, 6, 8, 10, 12, 14, 16, 18. Oh dear. I need a little more space. Well, this is gonna carry up into that one up there. Okay. 419. Okay, let's see here. What was our other ordered pair? There we go. 5, 20 and a half. So that was 19. Here's 20. Here's 20 and a half. 6, 21. So up a little further. 7, 20 and a half. So see how I'm just across this axis of symmetry? I'm just reflecting it 2 away, 2 away. 1 away, 1 away. And this is a nice wide curve of a parabola. So hopefully that's what you guys got. Ta-da! Okay, so now what we're going to do today is actually learn about being able to solve equations with this graphing method. So, you should have your notes out. We are going to be getting into 9.3, and again, like I said, this will be good review for your quiz. 9.3 deals with solving quadratics with graphing, quadratic equations with graphing. Okay, so we look at this and we see the equation. We remember what we learned from last chapter with having to set it equal to 0. And we say, okay, so how would I graph x squared minus 2x equals 3? Or solve it, sorry, how would I solve it by graphing? Well, first I gotta get it equal to 0, okay, just like we've done in the past. So I'm gonna subtract 3 on both sides, and I told you you always want to try to get the x squared to be positive. So x squared minus 2x minus 3 equals 0. Okay, so get it equal to 0. So here are the steps we're doing to solve. Step 1, get equal to 0. That's step 1. Okay, now step 2, sorry, replace the 0 with y. X squared minus 2x minus 3 equals y. Okay, so you're just replacing the 0 with the y. Now we have a quadratic that we can graph, right? Okay, so graph, step 3. So first we've got to find the vertex. X equals negative b over 2a, so negative, negative 2. Can I just start writing 2 now? Have you guys practiced that enough to know that negative, negative 2 is positive 2? Over 2 times 1, so 2 divided by 2 is just 1. So my axis of symmetry, my x value of my vertex is 1. Plugging back in, 1 minus 2 times 1 is 2, minus 3. So 1 minus 2 is negative 1, minus 3 is negative 4. So I have the point 1, negative 4. Okay, so now we make our chart. Right, we have x, y equals x squared minus 2x minus 3, and my ordered pairs. In the middle I have 1, 4, oh, sorry. In the middle I have 1, 0, negative 1, 2, 3. So I have 1, 4, I have 0, what? Boom. Negative 3, which means since these are integers, I have 2, negative 3 as well. Now I just have to solve for that negative 1. What's negative 1 squared? 1 minus, well, what's negative 2 times negative 1? Positive 2 minus 3. 1 plus 2 is 3, minus 3 is 0. So negative 1, 0, which means over here we're going to have 3, 0, right? Okay, so hopefully you're able to do this a little faster. I'm gonna let you make sure that all that's copied down. I'll give you about 20 seconds. Okay, so that should have been about 20 seconds. So let's graph this. Okay, don't need that anymore. We just need the points. And some graph paper. Let's see here, we're in the negatives, mostly positives, negatives, and positives. Okay. So we're gonna need both ends of it. Here's my axes. Here are my axes. Okay, -1, 0. So x is -1, y doesn't move. 0, -3, x doesn't move, y moves down 3. Well, something went wrong, didn't it? 1, 2, 3, 4. Okay, well, should this be opening up or down? It should be opening down, right? Okay. So I'm guessing it should be oh, look at that. I just wrote it down wrong. Well, that just goes to show you gotta pay attention to what you're doing. So that's wrong. Do you see what I did? I said -4, but when I wrote it in my chart, I wrote +4. Okay. And then -2, -3, and then 3, 0. Okay, the only difference between this section and last section is that right now we're trying to solve. We're not just graphing. So you've learned how to graph. Now we're actually trying to solve an equation. So we look at this and we say, okay, what does that mean? Well, we replaced the y into what number? The 0. So what do we know when y is 0? What is that called? When y is 0, there's something special that x is. It is called the x-intercepts. So what we're saying is the solution to this equation is the x-intercepts. So we've set it equal to 0. We've placed the 0 with the y. We've graphed. Step 4 is find the x-intercepts. So looking at this graph that we just did, where are the x-intercepts? Well, right there and there. Well, what are they? -1 and 1, 2, 3. So x equals -1 and 3. And it's as simple as that. Okay, so the only difference from the last two sections is that you just have to write down what the x-intercepts are. That's it. There they are. -1 and 3. Because we're solving for x this time. So we want to find a solution. Okay? Okay, I'm going to give you a problem. And I just want you to graph it. And if you find the solution, great. But we'll talk about it. So I'm going to give you an equation. In a minute, you're going to come up and pause it because this will take a little bit longer. So I'm not just going to sit here and wait. I want you... Actually, I'm going to help for a second, and then when I tell you to pause it, you'll pause it. Okay, so first off, what did I say that you want the x squared to be, typically? Typically, you want to try to make it positive because it tends to be easier to work with. It doesn't really matter, but it just tends to be a little easier to work with. It doesn't really matter. So we're going to subtract 1 on both sides, right? -x squared plus 2x minus 1 equals 0. Then, step 2, replace that with a y. Replace it with a y, and then graph it. Okay, so come up and pause and or give you about 2 minutes to not try to graph this, but to graph it, and then we'll talk about the answer. Okay, so you should have graphed this. You would have gotten -2 over 2 times -1, which would have given you +1. So that means that y would be -1 plus 2, because look, this negative is outside, so 1 squared is 1, and then it's negative. So negative 1 plus 2, because 2 times 1 is 2, minus 1, so negative 1 would be 1, minus 1 equals 0. So our vertex is the point 1, 0. X, y equals negative x squared plus 2x minus 1. Ordered pair, 1, 1, 0. 0, negative 1, so that would be 0, negative 1 because of that guy. Okay, so negative 1 squared is 1, so negative 1. Minus 2 minus 1, right? So negative 1 minus 2 is negative 3, minus 1 is negative 4. So negative 1, negative 4, reflect across this axis of symmetry to negative 1, 3, negative 4. Okay, so then we graph it. Okay. So we have, let's see here, negative, positive, mostly negative y's. Okay, so negative 1, negative 4, negative 1, 1, 2, 3, 4. 0, negative 1, 1, 0, 2, negative 1, 3, negative 4. Okay, so we're actually trying to solve for x. We're not just graphing now. We're actually trying to solve for x. So what did we say was the solution to x? We said it was the x-intercept, right? Okay, so what is my solution here? X equals 1. So there's just one answer. That's it. Okay? And if, we're not going to get to this today, but if I graph something, and it looked like this, does it even have an x-intercept? No, so what would the answer here be? No solution. Okay, so that's good enough for today. We'll continue going through this tomorrow after your quiz. Study hard tonight. Make sure you understand, ask questions. I'm telling you now, it'll be 3 graphs. That's it, 3 graphs you have to graph. Okay? Good luck. Goodbye.